This is Mrs. Naslin, and today we'll be doing Unit 1, Lesson 2, Tables of Combinations. Our learning target for today is, I can use tables and other methods to solve problems involving combinations. So, combinations basically is when we combine information together, and we can use tables to help us do that. So let me show you what I mean. It says, a restaurant makes veggie pizzas with 2 types of crust, thick or thin, and 5 toppings, pineapple, mushrooms, onions, green peppers, or black olives. You can use a table to show all the possible one-topping pizzas. Copy and complete the table to show all the combinations. So basically, the combinations are all the different things, or different types, in this case, of pizza that you could actually create. So for example, if I combine pineapple with thick crust, I'd have pineapple or thick crust. If I do these two, I'd have mushroom or thick crust. Mushroom, I should say, on thick crust. There we go. This one would be onions on thick crust, green peppers on thick crust, and then black olives on thick crust. Then we can look at all the possibilities when it comes to the thin crust. So I could have pineapple on thin crust. I could have mushroom on thin crust. I could have onions on thin crust. I could have green peppers on thin crust. And lastly, I could have black olives on thin crust. These are all one-topping pizzas, right? They only have one topping, but you can either get them on the thick crust or you can get them on the thin crust. So the first set of questions here says, look at the rows in the table. So remember, rows go this direction. It says, how many one-topping pizzas have thick crust? So look at the thick crust and how many one-topping pizzas, so all of these are one-topping pizzas, have thick crust. So we've got 1, 2, 3, 4, 5. We've got 5 different pizzas. How many one-topping pizzas have thin crust? Well, we've got 1, 2, 3, 4, 5. Okay. What addition equation could you write to show the total number of one-topping pizzas? So how could I write that as an addition equation? Well, I know that I had 5 thick crust one-topping pizzas and I have 5 thin crust one-topping pizzas. So I could write the equation as 5 plus 5 equals a total of 10 pizzas. What multiplication equation could I write? Well, I could say I've got 5 different types of pizzas, and I can multiply it by 2 because I've got thick and thin. So I could say 5 times 2 equals 10. Okay? Now it says, look at the columns in the table and answer the questions. So now we're looking at the up and down, the columns. It says for each topping, how many different pizzas are possible? So I want you to go ahead and take a guess on that one. For each topping, how many different types of pizzas are possible? All right. If you said 2, you were correct because we have the possibility of a thick crust pizza or a thin crust pizza. What addition equation could you write to show the total number of one-topping pizzas? All right, well, we know that there's 2 for each of these. So there's 2 pineapple, 2 mushroom, 2 onion, 2 green peppers, and 2 black olive pizzas. So I could say 2 plus 2 plus 2 plus 2 plus 2, right? I could write that out 5 times, which would add up to 10. What would be a better way, what would be a multiplication equation I could write to show that? If you said 5 times 2 equals 10, you were correct. All right, great job. Let's try to make some of these combination problems on our own. So this one says, on a separate sheet of paper, Make a table to show all the possible combinations. Then write a multiplication equation to show the total number of combinations. So if you have a sheet of paper, I would take it out and let's go ahead and do this together. It says Rashawn has blue, green, red, and white t-shirts. He has black, blue, and tan pants. How many different outfits can he make? So I'm going to put a table together real quick. We know he has blue. I'm just going to write T for t-shirts. He has blue t-shirts. He has green t-shirts. All right, I have to make this a little bigger. That's all right. Green t-shirts. There we go. He has red t-shirts. And he has white t-shirts. Okay. And then different types of pants. He's got black pants. Put P for pants. Hopefully this will let me spread it out a little bit more. He's got black pants. He has blue pants. And he has tan pants. Okay. So then I could go fill all of these in. I could say, and I'd have to make my font really small, so I'll shrink it down just for one of these so you can see. But I could say he's wearing a blue t-shirt and black pants. You see, I'm getting that because I'm taking the blue t-shirt and the black pants. In this case, you'd have a blue t-shirt and blue pants, a blue t-shirt and tan pants, right? So all of these are going to be filled in with different combinations in the end. So they want us to write an equation, a multiplication equation, to show how we could figure out how many different combinations it can have. Now I'll show you a little trick. What I usually do is I count the number of options for each. So in this case, t-shirt wise, I have 1, 2, 3, 4 options. For pants, I have 1, 2, 3 options. Now if I multiply 4 times 3, I should get the total number of combinations. And we can count these squares to see. So 4 times 3 equals 12. Let's see if we have 12 different combinations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it worked. I ended up with 12 different combinations because I did 4. Because I had 4 different types of t-shirts times 3 different types of pants. All right, let's try one more together here. All right, this one says, Mr. Estrada has blue, white, gray, and pink dress shirts. He has a plain tie and a striped tie. How many different shirt and tie combinations can he make? So I'm going to use my little table to help me here. I might shrink my font so that I can fit more in here. We have blue dress. I'm going to just put a D for dress. A white dress. Oh, it's big again. I want to keep my font nice and small here. A white dress. A gray dress. And lastly, a pink dress. And for my tie combination, I said dress, but it's really a dress shirt. You probably wouldn't want to wear a dress. Dress shirt. So now we have to look at his ties. So he has a plain tie, put a T for tie. He has a plain tie. And lastly, oops, he has a, of course I can't see it anymore, he has a striped tie. All right, so if I was going to actually combine all of these, I would end up saying that he had a blue dress shirt, with a plain tie, right? And then I'd say you had a blue dress shirt with a striped tie and a white dress shirt with a plain tie. So I'd fill all of these in. Now I want you to think back to what we did on the last one, and they want us to write a multiplication equation to show what we would multiply to find the answer. And remember, I gave you a hint about counting your options when you're doing your multiplying. So see if you can come up with your multiplication equation, and then we'll compare and see how it works. So let's see how you did. First, I would count the number of dress shirts. So we've got 1, 2, 3, 4 dress shirts. So we've got 4 dress shirts, and I'm going to multiply it by the number of ties. We have 2 ties. So I multiply those two together. I would end up with a total of 8 combinations. All right, let's just confirm that's right. Yep, 8 combinations. Great work. So today we talked about using tables when looking at combinations of data.